My name is Dr. Ken Kavami from the University of Arkansas. What I'm sitting next to here is a ground penetrating radar. What this device does, it sends microwaves into the ground, and as the waves go down, they reflect off of things that are buried. So whenever there's a discontinuity, something different, we get a wave that comes back to the surface and it's recorded. And as we move the antenna, it's a small box across the surface. It's continuously sending waves into the subsurface. We send about 40 per linear meter, roughly a yard, into the ground, and it goes down. Right now I have it set for nearly 3 meters deep, and on the way down it reflects off of everything it hits. And so what we get as we pull this along a line is a profile of reflections, and those reflections indicate stratigraphy, or natural changes in the soil and sediments. They indicate buried rocks, tree roots, stones, ancient floors of houses, hearths, storage pits, whatever is down there, basically. So we run this transect. Right here we're running them about 45 meters long. Then we stop and move a half meter over and then run it back. And we go back and forth all day until huge areas are covered. Right now we're doing a 90 by 90 meter space every half meter. So basically it's blanket coverage of this whole space, and then we can slice that profile down and create plan maps in whatever depth we want. So we could do a plan map at a half meter, 1 meter, a meter and a quarter, or whatever, going down, and we could see where things are buried then. And what we anticipate finding here are basically native Arikara houses near the surface, and deeper down older Mandan houses, because at the site the Mandan occupation was earlier than the Arikara. Well, over on my in the far distance there is an orange box. That's the actual radar antenna, and they're rated by frequency. That's what we call a 400 megahertz, and so that's a medium frequency one, and it's pretty ideal for archaeology. We could go, we got good data all the way down to maybe 4 or 5 meters, depending on soil. And then behind the orange box was a wheel, and the wheel controls the location of the antenna. So out of that box, the energy goes down in a small cone, and it reflects off of all the buried archaeology. And then we have a long cable that connects to the actual computer that runs the radar. And what we see on the screen is a bunch of stripes, because right now the antenna is not moving, and that's showing the reflections at that point in the ground. And we can see there's a surface reflection, and then various layers it's reflecting off. And because it's not moving, it could be just a rock, a rodent hole, or maybe a house floor. And we have on the far right, I don't know if you could see this, is a sine wave. That actually shows the strength of the reflection. So if it's a real sharp difference, there's a large reflectance. If it's just a small difference, it's a lesser reflection. This unit is made by Geophysical Survey Systems Incorporated. It's called the SIR 2000. It's an older model now. It's actually ancient because it's about 10 years old. There is a newer system out that I also have access to, but it's on another project now. So I'm using this one here, and it works just fine. And so I just have a basic control console with all these keys. I can control the system and tell it how deep to go, how to record the data. There's a hard disk in this. It records the data onto a hard disk, which I download to a computer in the evenings to make a map of what we found, basically. Okay.